To start, we have some issues with the streaming. Actually,
Yeah.
I have to tell you, it says your broadcast has ended in LinkedIn. I don't know why
Oh,
this happens. It's the second time it happens for us. But
okay. I
anyway,
think it's
hi Raj.
hello. Welcome back
Hello.
again.
Yeah, it's the second try we do. Okay.
No worries.
So yeah, new webinar, keeping or continuing the trend in the last two webinars. Tell
Mhm.
me, what are we going to see today?
So I've created a demo
Mhm.
where you can see on the screen there is a robot which is moving, doing some pick and place action. This is nothing new. We have seen that in the last webinars as well.
Mhm.
But what's new is this time we are doing the product sorting using AI.
Cool.
So if you see on the top right, there's a URSim simulator, which is
Mhm.
just controlling the robot. And we are running this simulator on Dockers. We talked about that in the last webinar, how
Mhm.
we can do that. And if you see on the bottom left, there's a preview of an image. So how is that image coming? So what is robot doing? Robot is taking a photo, not robot, but a camera which is connected on
Mhm.
the robot gripper. Maybe you can go to the next screen, which
I
has a
can.
full screen view.
Yeah. Yeah.
So there's a tiny camera next to the robot gripper. It is taking a photo and it's sending the photo via FTP to a Raspberry Pi.
Cool. Mhm.
So the camera has possibility to either send the photo directly to your computer, or you can use FTP and send it to any FTP server which is running in your networks. In this case, it's running on Raspberry Pi.
Okay,
So
directly from Simumatik to the Raspberry Pi.
exactly,
Mhm.
yeah. So Raspberry Pi has an IP address which I give it to the camera, and then it send it to the server. For sure, it's secured. You have username, password, and it's a secure connection.
Mhm.
And now, once Raspberry Pi has the image, I read that image using Node-RED
Mhm.
as a file node. I will show you shortly. And then I send this image to Teachable online platform.
Oh.
Okay, this is a platform from Google that you can use for free. It's a very good source of learning.
Mhm.
And there you can put your classes. So you upload some samples and you create classes, and then it will tell you which image is linked to which class.
Yeah.
So I can show you shortly. So
Yeah.
basically, all the image detection is happening online on
Online.
Teachable
In the cloud. Yeah. Okay.
in the
Cool.
cloud. And then I get the result back from the cloud, bring it to my Raspberry Pi, and then Raspberry Pi send the result via OPC UA
To
back to
CODESYS.
my CODESYS, and CODESYS send the result to robot. So it's a
Wow.
lot of things happening.
Yeah, it's a lot of systems going on. So you have a model
Yeah,
running the camera and the robot and the conveyors and the
right.
boxes. You have URSim to control the robot, CODESYS to
Exactly.
control the PLC, and then you have the Raspberry Pi with Node-RED
Yeah.
and sending pictures to this Google service. Yeah.
Yes.
AI kind of thing. Yeah.
And there's another slide. If you just go
Yep.
next, there I've
Mhm.
mentioned the workflow. So there you can see. So we have a Simumatik on the left. It is connected to URSim by an API, which is controlling the robot. And then in Simumatik, we have a camera sending FTP, sending an image via FTP to Raspberry Pi.
Mhm.
Raspberry Pi communicate with this Teachable online, send the photo, get the result, and the result goes via OPC UA to CODESYS,
Mhm.
which is connected again to Simumatik, and Simumatik send the signal to URSim.
Cool. Wow. A
Yeah.
lot, but
So
it's
this is
super cool lab. I mean, you can do a lot of, you can train a lot of things in this lab: PLC
yes,
programming, robot programming,
right.
image recognition, and so on. So
Yeah.
it's gonna be cool. So, what are you gonna show in the details today?
I think we can first talk about the system
Mhm.
which is running. So you can maybe share my screen. I can talk about what is in our system, what elements do we have,
Mhm.
and then I can talk about how the system is linked to URSim shortly.
Mhm.
And then we can talk about how I'm sending the photos from camera to Raspberry Pi. And then I have a small demo. For example, right now you see on my screen, I have just 3 boxes coming, green,
Mm.
red, and blue.
Yeah.
I can create a live demo to include another box, which is an orange box, and train these images into the
Mhm.
Google service and see the result live
Cool. What
that
we
we
are
can do.
seeing is just what is going on in your laptop. So this is
Yeah,
real time. Yeah. Cool.
Yeah, this is real time.
Mhm.
So right now on the left side is Simumatik. Here on the top right is URSim. This is my Node-RED on Raspberry Pi. And what I have not shown here is my CODESYS.
Yeah.
This is nothing new. We have been doing this in all the
Yeah.
webinars.
Yeah. Yeah.
CODESYS is controlling the conveyors and sensors and
Okay.
robots.
Cool. That's
Okay.
very interesting. Yep.
And when I was talking about image recognition, if you see on this tab here, these are the classes that I have defined.
Mhm.
So I have a red class, green class, and blue class. So these are the sample photos. So what I do, I first bring the object here, and then I take sample photos, and then I upload these photos in Teachable Machine and define different classes based on which color I want to sort. And then I click on train the model. It trains the model, and then you can test your model here. So basically, you can just put your image. Let's say I put green image here, and then you will get the result. It's 95% green. So it is giving me probability as well. It's saying that maybe it's 2.5 red, 2.5 blue. So here on the right side, I don't know if you can see this number. There is a number here, which is telling you the probability. So when it takes the photos, you'll see a photo here, and it says 90% green.
Yeah. This
So I take
this
this. Yeah,
teachable thing from Google. How did
yeah.
you get to know it or?
I think just by searching on internet, I actually made a video using flow views. I was experimenting that as well, in which I was showing a live photo from my camera. So I had different emojis in my hand, and I was showing this emoji to the camera, and it was giving me the result. So you can do. You can also train photos from the live camera directly to also using Google.
Yeah, and is it free? You said
It's a
it's
free.
free. What do you
It's
need?
the
Just a Google account?
just a Google account, not even an account. I don't even sign up as well. You can just use it without signing up. And I have linked my Google Drive to save my model, this training model.
Cool.
You can also download this model and put it on your Raspberry Pi directly. So you don't need a Google services as well. So they have a TensorFlow Lite and normal TensorFlow. So you can take any Linux-based edge device and you can deploy that there as well.
Cool.
But you can also use online if it works easy.
It looks very simple to set up. Just uploads a bunch of classes
Yeah.
is what you want to be able to identify. A class is kind of a different item.
Category or
whatever.
identification, you can say.
And you can add new classes. You just need to tell with some samples how this class looks like. And then you train it and so on. But you will show that how you do.
I will show.
That. Yeah, great.
We come to that sooner. So that was how the image has been classified. And the interesting part, or the part which I would love to highlight, is the camera. So here you can see I select the camera. On the right side, you will see some parameters. And here we can see the IP address, 192.168.0.152. This is belonging to my Raspberry Pi. And it has a username Pi, password Raspberry, and this is the upload path, FTP, just the FTP, and timestamp is false. So every time the camera makes a photo, it sends one photo to the Pi. And when it make another photo, it will just replace that photo. So it's only one photo going to the Pi. And this is a resolution. So let's see what is happening in the system. That's a very basic system. You have a conveyor. We have here on the left side product entry. And here you can see I'm sending 3 products, red, blue, and green. And that's it. It's running on the conveyor. And as soon as this sensor detects the objects, it sends the signal to the robot controller. So we also have a robot controller here, somewhere, I think in the backside here. So this black box is a robot controller. And these two are the robot IOs. So robot has its own input-output modules. And this robot IO is connected to the PLC IO, which is inside here. So PLC is talking to the robot via digital IOs, sending the signal, which is like if the sensor has detected the object, and some handshaking between PLC and robots. And here, if I show you again robot controller, although we have talked about that in the last webinar, we are using UR driver. And this is connected to my URSim running on the Dockers. And this is the port address, 30,004.
Yeah, I see the Docker running there.
Now, there is the Docker running there, and you can see these are the all ports. So we talked about that more in the last webinar.
Yeah,
so they're interested, they can check this webinar.
Mm-hmm.
Nothing much here in the URSim. We have just a program which is running and comparing if the photo has been taken, if the product is blue or green or red. Based on that, I have 4 programs which is doing pick and place to different locations. Typical robot programming.
Good.
That's it. That's what's happening here. Now, if you have any question, you can ask me. Otherwise, I will show you a live demo of the new box.
I would like you to tell us a little bit about this orange block in Node-RED.
All
because
right.
that is where you do the trick, right? This is how you communicate with the Teachable, and you get you send the picture, you get the result.
Right. So what I do is now I take my product entry, and here I have 4 products. I'll just remove it for the sake of just getting one orange mini box. And first I bring this to the photo area where we will take photos. And I will stop this robot program. I have made a new program in the robot, which is just going to take photos. So I open the program. Okay, I have to make it bigger for a second. And this one is take samples. I open it, minimize it. Now the object is here. Now I want to take different samples. But for that, sorry, I forgot that. I have to first change my camera path. I want to take photos in my desktop. So here we have the path which is going to Raspberry Pi, and I have saved the path here just to save some time. I'm going to save that into my B directory, and here I will make timestamp true because I need multiple photos, and I change the FTP to disk. And I have to maybe start again. Okay, let's start the conveyor again. And we wait for the box to run. So every time when you introduce new product, you have to first make photos. So let's bring it here, and now maybe I zoom out a bit, and let's see if it can generate. The photo should come here in my D directory. You will see here shortly. And maybe I can bring it here. And I start the robot program. Okay.
Oh, cool.
So it's going to take photos. You can see photos are being generated at different angles. So it will take 5 photos. That's how I program this robot. Or maybe just 4. Sorry. So now
you had 4. Yeah, you have 4.
I have 4. So now I will upload these 4 photos to my Teachable. So I will create first a new class. So you can see, maybe you can move your camera.
I'm gonna move
or bring it somewhere else.
Come here.
So there is a button add a class. I click on that, and now I can rename that to orange. Press enter, click on upload, and now I can drag my samples.
Oh, that's easy.
And that's it. Now you just click on train model. So it will start preparing the data. So
okay, this one has 1 picture less, but it doesn't complain.
Yeah, it's okay. It's actually much better to have as many photos that you can give it to the AI that will train itself. But this will work very good. So once it's trained, you can just test here before checking it on the system. So here there are 2 options. One is webcam and one is file. So when you click on file, now I drag my orange photo. I get probability, not so good. Let me see one more time. Oh, I have orange 100%. And here 98%. Here, this is not so good. Oh, okay. I think this is going to, I believe this is taking square photos because I don't see complete photos here. Let me try one more time. This is okay, 98%.
I think we can live with that one.
It's okay. Now it's good.
One
Maybe
question,
the last one.
Cannot you now give some feedback to the model? Like telling, okay, this is actually orange, so you kind of train it even more. No,
unfortunately not. Here it's not possible. But if you see, this is the photo that usually robot will take.
Yeah.
And this is the angle which will take. So it's 98% orange. And we can check with others. This is red. This is blue. And this is green. Oh, this is
no, it kind of messes between green and
maybe I can take more samples and we can train that again. But let's see, because I just added now orange, and let's see how the system behaves with that.
I mean, that's we are just testing.
And then once you test it here, it's still 76% mix. It's okay. We can click on export model. And now here you can see there are different options. I will click on TensorFlow.js and I get a link. So this link I can copy. I anyways did that before. And then you come to your Node-RED. And this teachable machine you can download from the flows. So if you go to Manage Palette, you click on Install, and just type Teachable Machine. This is already installed. And then you open it, and you just put the link here. And then it is going to tell you if you need the best prediction or all predictions. I select the best prediction, then I got the prediction of the best score.
Highest score. What do you have before that block? It's just the reading block?
So yeah, good question. I can maximize it. So that's my Node-RED flow. On the top, I'm using an OPC UA tag, and I'm reading from the OPC UA server. So OPC UA server is defined in my CODESYS. So CODESYS, if you see here, I can maximize it. We have some variables. If you see here, there is a vision result, trigger vision, test vision. So, and we have some inputs and outputs. So in PLC, I am reading some data. For example, if you see here, here must be photo captured. So when photo has been captured by CODESYS, I read it in the Node-RED. And when here you can see the photo taken, I take the feedback, and then I go inside my Pi and capture that photo.
Okay, so that's the camera image sent by FTP to your Raspberry Pi.
Exactly.
That's the path. Yeah.
Exactly. If I bring it here, I can also show you, maybe not this one. I can take image preview, put one step before. You can see here preview as well. But here you will just see the preview, and here you will see the result if it's green or blue. And then this image is directly going to Teachable. It's running its model, and then giving you a result as a JSON. And this result will be what is the class and what's the percentage of that class. And then I send the signal back to my CODESYS, and I tell it, if I open this one, if the class is blue and the score is more than 50%, then send a payload 1. If the class is green, then send payload 2. If it's red, and if it's outside these range, then you send -1. So one payload will bring the box to one location. 2 payload will bring the box to another location. This is what I do then in URSim, based on what is the feedback coming. So that's the whole story behind the logic.
What will happen now with the orange box?
Okay, now what we did, we have uploaded the class, we have trained the class, and now it's up and running. So what we can do is now we can bring all the boxes again and see the results. So I will go to product entry, now add all the boxes, because it was, so I have red mini box, and add product, blue mini box, and we have one green. And there's another interesting example we can also play around. I don't know this one. When we have random colors coming in, which you just helped me a couple of minutes ago, we can also train that. Okay, so now we have all the boxes coming in, and we can also deploy this one. So OPC UA is running, this is running, and CODESYS I have to start. Let's play. So now we can see here in the preview, orange, class, and the result. Okay, now we already have this orange coming in. I have to start the robot program.
Yeah, you need to change it, or? Or did you
Yeah,
change it to the?
I need to change it. Yes, I need to change it. The 3D camera sorting. Open. Play from the beginning. So it should take sample, because I took time limit, it will move shortly. Let me see here. Oh, now it's working. Okay, this is, I think, the last photo. I have to check that again, which is taken from the Raspberry Pi. Oh, sorry, one thing we also forgot to change. I have to change the path.
Yeah, you are not sending the picture here.
Now it's still going to my computer.
Yeah.
So I was wondering why it's the wrong photo. So I have saved the path here. So a lot of things you need to change before you.
Yeah, now you will be back sending the pictures to
yes.
the Raspberry Pi.
Yes.
Okay.
So let's see. The first one is the orange one. Okay, this is the last operation. I did not reset the, so they did not take the photo. Let's try one more time.
Okay,
so
there
right now it's red.
We have red picture. Yeah. Now I was wondering, because in your Node-RED you are just checking if the class is blue, red, or green.
I know.
So what happens when it will say now it's orange? Or
actually, I tell you, I only have 4 boxes in my Simumatik, and I say if it's besides red, green, and orange, red, green, and blue, just put it in the 4th box. So it will anyways do here. What I just wanted to show you here on the right side, that you will see a class.
Yeah.
This is the rest you can program the way you want.
So basically, the orange will behave like a box of an unrecognized color with a score lower than 50%. So
yeah, I mean, I can also change that. Now you can see it's orange, 70%. Yeah. I can also change here the text. Okay, if the class is orange,
yeah, of course.
Instead of else, then also payload will be the same -1.
That's cool. Okay, cool. It was pretty easy to set up.
Yeah, you see, few minutes and you can do image recognition. So easy.
Yeah.
And what we can also do now, we can play around with some boxes colors. Because right now you might see the percentage is always, let's say, 94, 95, 96, because it's the same image and same boxes are coming. If your boxes colors have some variations, this variation could be because of the lighting environment in Simumatik or in real life, or there's some different box coming in. You can measure that in your Teachable, because it will give you a score based on what's the color. So what we can do in Simumatik, I can bring it another box. It's a special box which will help us to have some variations in the color. So I go to product entry, and here variables, I add a product, and this was called vision, random color vision. Okay, so this product has some noise added to these 3 colors, red, green, blue, and orange. And this will just change the color fading, or I don't know, brightness or hue. So this will be changed a little bit. And this is programmed in a way, I think I can't show you here, but I can show you when the product is on the conveyor. And then we will see some variations in our object.
Now the thing is, it's going to be every 5th box is
every 5th box.
I can one of those. Yeah.
I can also remove the other one, and I can see. So I don't know if I can do it in real time, or do I have to restart it?
No, I think you can do. Yeah, I think it may be.
Oh, no, now you can see.
Yeah.
So this is not green. This is a little bit lime, I would say.
Yeah.
And then you should get different 71% green. Now it's
still green.
So, yeah, still green, but 71%. Yeah. So you can play around with the score. I took more than 50%, then just take it. But if you are more accurate, you want more accuracy, you can do more than 80%, then you recognize it's a good box. So you can play around with that. So this was just the idea how you can make some exercises if you're learning on this environment using Simumatik, image recognition, robot picking place controller. Now this looks a little bit more pinkish.
Yeah.
Yeah. So this was the idea how we can integrate different technologies together to do some demos on digital twin and AI.
Yeah, it was very interesting. Maybe we can show how we did this random color box.
Oh yeah.
Yeah.
So this I can.
Yeah, you can leave it up and running.
Yeah, I can leave it up and running. So let's say, but
you don't have one. Yeah, you have it somewhere.
I can go here. Vision, random color. So it's basically a normal box, like you usually take in a visual. You take a geometry, it's a box, and you have a size here. So, and in the behavior, okay, maybe I can maximize it. We have written a piece of code. This is what you are more expert than me. Maybe you can tell me more about that.
No, basically what we did is that we got the colors in your 4 boxes.
These ones,
the red, the green,
red, green,
the blue,
and orange.
and the orange one, and just we add some noise to those colors. So just get a random number. Just first random number is to pick one of the colors, the base color. So this will take the
any of these.
Yeah, any of those. And then on top of that, once we have taken the color, then we take we add some noise.
Okay. So basically, you take a Boolean input to enable or disable the noise, right? Okay.
By default, we have it activated just to
add noise. Okay, it's true. Okay.
And then basically we create a value between 0 and 1, but we convert it to -1 to +1. So with the first part of this function, and then we multiply that with the noise. So we can get in any of the 3 elements, the red and green and the blue one, we add some noise. It can be in all of them, but it's different. So that's why it varies a little bit. And that's all. It's just a way to do it, and you can do it if you do it in the you do this kind of stuff in the initialize part of the behavior. You can generate random elements. So these actually, each time you create an instance of this box, it will be different.
That's right. And you can limit how far the noise can go.
Yeah, with the noise amplitude variable.
Okay. And you also mentioned, lastly, you can also change the size of the object.
Yeah, and we can do that. We can do that. It was just a bug we detected in the 3D engine. So in the pictures, it wasn't working well, but we are going to patch it. So when you modify the size, you can see it in the workspace, but it was just the pictures were not reflecting that correctly because of bug in the 3D engine for the cameras. Yeah. But it's a lot of things you can change in the initialization. You can change the friction, you can change mass, and all this kind of stuff.
That's right.
If you want to randomize.
Also the weight.
Yeah.
It could be used in the weighing application to sort the boxes based on weight, for example.
Yeah. So based on weight, size, and so on. So you can add some randomness to products.
That's right. Because before we were making different objects with different colors and different weight. And we have to copy that and change the properties. Now we can randomly assign it.
Yep.
That's very nice. Okay, cool. So yeah, this is what we implemented here. There is someone on my door. Okay. Well, yeah, this was not too much to.
It was quite much.
On the back end was a lot.
Yeah. I think it's quite much just to set up all this. It's several applications running together, so I think it's.
But the good thing is it's very easy and flexible. With Simumatik, we can easily connect to URSim by click of a button because we have ready-to-use drivers. And with CODESYS, we are doing since forever, used by OPC UA. And rest is just a Raspberry Pi running it. It's also OPC UA and FTP connection. So we have FTP, OPC UA, and this API with URSim 3 interfaces.
Yeah, it was cool to see that you could easily switch between sending the pictures to the Raspberry Pi or saving them into the into the disk. It was pretty cool, the program you did for the robot, just to take these pictures. It was a very good idea. So you could, I mean, it will be nice to see if you start adding more classes, like maybe other objects, and just train a little bit the model with this, I don't know, a little the DAC we have and things like that, and see where are the limits of this machine learning AI, whatever we want to call it, thing from Google. I mean, because now we are checking mostly, I guess, colors, or I don't know what's happening behind the scenes, but I guess
you can check the shape as well, and I think it depends, because it's going to check the pixel. It is going to do the same what OpenCV is doing. It will check all the pixels, which one is, how many pixels are red and green and blue, and what's the length of the edge. All these things it is doing in the backend.
Is there any configuration for the model before you train it? Or?
There's one configuration, depends on here, epoch and batch size and the learning rate. There are 3 parameters here. I did not play around much with that, but I think this is going to tell you how much accurate you want your model to run. Here it says you probably want to tweak, usually increase this number until you get good predictive results with your model. So you can play around with the epoch number, and then the batch size. It's a set of samples using 1 iteration of training. If you have 80 images, you choose a batch size of 16. This means the data will be split into 5 batches. So I think it's about the training and the learning.
I think you have uploaded too few pictures.
Probably.
It can be way more robust if you have more pictures. So
I mean, when I did a live demo with the camera, you just put the object in front of the camera, it automatically takes photos. So you have 100 photos in 2 seconds. It has a capacity of taking a lot of samples and give you the right results. So, and they have another model inside Teachable. I don't know if I can open it here, where you can analyze the, how do I say, the posture of your body. If you're standing or if you're laying down, if your hands are like this or like this, it can tell you the posture as well.
Cool.
And this you can also use, maybe kind of like a sign language. You can tell the machine or to stop the machine or run the machine, things like that. You can do as well. And third one was also the audio. It can analyze your audios. I have never tried that before, but these are 3 inputs you can give to Teachable Machine and you can get a result. I mean, if you think about Simumatik, I think image recognition is the best suitable way to connect to Teachable and practice some exercises for your students, for your, I don't know, academy, whoever is using it, and also just to play around with it.
One thing I was thinking about that when we were discussing about randomizing colors and so on, it would be, it sounds that it could be interesting to be able to randomize the orientation of the product when it's introduced into the system as well. Because that way maybe we could kind of obtain different picture.
That's right.
Sorry.
And what we can also do based on position, because now it's coming randomly of the object, we can also tell the robot where to pick the object. Right now it's just looking at the fixed location. If the orientation is different, it has to orient as well, the gripper.
Can you get the position of the object?
This we don't get from Teachable Machine, but we need to use any other program for that. We can find out, maybe OpenCV can help, or some other
if you get the shape or the contour of the object, then you can do some calculations.
This we can calculate, and then we can tell the robot to move a different set point to pick the object. This is another way. Maybe we can try that in the upcoming webinars, how we can do this precisely positioning.
Really interesting. I hope the audience likes this webinar. It shows a lot of possibilities. I mean, this very simple station in Simumatik allows to learn robot programming, PLC programming, Node-RED, even a little bit of vision. So I think it's really, really, really cool.
I mean, I'm running this Node-RED on Raspberry Pi. You can also run it on your computer or any other edge device as well. So you don't need to have a Raspberry Pi. And I think we can share this project in our academy, and people can download it, because I have this Docker file of URSim.
Yeah.
I can create a new image, so they have the program already inside, so they don't have to reprogram it, and they can do some tweaks if they like. And then we can upload this project of Node-RED and CODESYS, and then they have ready-to-use a package that they can start downloading and running it. This we can do.
Very, very interesting. Yeah.
Do you have any ideas for the next webinars? What do we do?
I don't know. Maybe we can keep this trend as with the URSim and the ambition and so on. I think it can be interesting if we can show how to change the shape of the shape and the size maybe of the objects. It could be good. And we think I think we need to discuss if we may need to add some new parameters to the product entry, so we can randomize as well the rotation in the entrance. If we want to add some variation there.
I think by doing the rotational axis, we can change if the product is coming bit at an angle or straight.
I mean, we could allow some degrees of freedom somehow. We can think about that.
Okay. Cool. And then we can try that in the next webinar next month.
Cool. But then I think, let's see, I'm gonna switch the screen. Here we are. So if we don't have any questions from the audience, I hope the streaming was okay. So
I see there are 9 people joined in, but not saying a word. I mean, guys, feel free to write some messages if you like. We are still here for another 2 minutes, and if you have any questions, we can answer.
Otherwise, they can leave the comments in the YouTube.
That's right.
Video when we publish it.
Okay. Any new features that you want to talk about?
That's what I was thinking about. That we are working in different stuff. Recently, we have deployed a new version of the app. I think people have seen this tool to orientate the camera.
Oh yeah.
Maybe you can show it. Actually,
I can show it if you can bring up the screen again. So here on the top, you can see I can visualize at a different orientation. This is a very cool feature. I really like it, and which I think we should be having. And I would also like if we can integrate our 3D mouse and move the orientation with the 3D mouse. If there's some kind of interface we can do, that would also be added.
That would be cool. So that was one thing. Recently, we have been doing some cleaning on bug fixing. The team is working in a really interesting feature to be able to show kind of interactive screen inside the model. So you will be able to open kind of a screen connected to a URL and interact like a web browser. So
kind of like an HMI or something.
You could have, and this is something that as soon as we have it up and running, we are gonna do the experiment with CODESYS and the web visualization. Because hopefully, if everything works well, we could have the web visualization of CODESYS inside the model and interact inside. And it will be good to see it with Vero as well. So you jump into the model and then be able to play with the HMI inside the model.
So it can get only the HTML pages.
Yes, this is a feature that you open a kind of frame inside the 3D environment, and this frame is basically an iframe that connects to.
You can also check out then the Node-RED dashboard inside. Also visualization and kind of like an edge. This will be a really cool feature.
So as soon as the guys can deploy it, we will have a nice webinar about that.
I can also imagine if you are using Simumatik to take examinations, so you get your exam on this iframe. Okay, this is the step 1, do this. Step 2, do this.
I mean, you could have an interactive screen where you get instructions and so on. That's one of the ideas, but the main idea when it comes to the industry customers and so on is to be able to have the HMI inside the model. Because now when you have the robot cell or whatever you are building your machine in Simumatik, you still need to have the buttons to interact with it inside the model, but the HMI you need to have it outside. And when you are jumping in with the VR, Googles, and so on, then you cannot access the HMI. But we can see more and more that the manufacturers are developing this kind of web-based or serving through HTML their HMIs. CODESYS has been doing it very long time ago. I think other manufacturers.
There is another one, Smart HMI. They also do it web-based HMIs. And PLC Nick also has web-based visualization, so from Phoenix Contact.
Yeah, so I mean, I think it's gonna be more common, and we want to be able to show that. So that's.
I mean, you can also do SCADA screens. They are also HTML-based, so you can run a SCADA software inside.
That's and let's see what else we can have in those iframes. I mean, the limitation is gonna be that whatever we want to have it needs to be compatible with iframe, and not all the sources are compatible because of security reasons. So YouTube, you can have a YouTube video, but maybe you cannot have something else. So that will be a limitator.
Okay. Great. We have one comment from Jack Sat. He's saying, "Thank you, interesting. We'll investigate it more."
Cool.
So feel free to do that, Jack. Happy to hear that.
Yeah. So on what else? I don't know. It's a lot of going on in the workspace as well. A lot of improvements we are testing, performance improvements, and so on. Even looking to new physics engines, so we can support more accurate for industry users. So yeah, I think it will be a lot of news coming on during the spring and summer, and we can do webinars about that. Yeah.
And maybe just for the users, we are also launching our newsletters shortly. So you will have information about what we have done in the first 4 months, some brief about all the articles, all the webinars, all the updates of the software and the workspace. You will have all in one document. So feel free to subscribe to that. You can see that in our LinkedIn page, newsletter very soon, and then you can subscribe there and you have all the information for every 4 months. We are going to do that quarterly. Yeah.
Perfect. But then thank you. It was really nice as usual. So
thank you, Mikel.
See you in the next webinar, and thank you everyone for joining us.
All right. Thank you. Thank you for joining. Have fun. Bye-bye.
Have a nice day. Bye-bye.
Bye-bye.